So now there is a third group of people who are working on the NICs. So there are two people. First, who make the NIC. Second, who make the switch. Sorry, people who make the hypervisor and the people who make the switch. Cisco versus VMware. And they came up with those alternatives that we discussed. But then there is something in between, which is the real NIC, which is made by Intel. What can Intel do in this business? And so they say, no, we have a solution which does not require you guys, and in their sense it is better. And so their solution is based upon PCIe. Now what is PCIe? All of your computers have PCIe, you know that, right? PCI Express bus. If you have a desktop, sometimes the port comes out and you can see it. If you have a laptop, the port doesn't come out in most of the laptops, but in some it does. But that's the bus, which is very high speed bus, which connects all the peripherals inside your computer, a CPU, to video, to storage, everything. Right? PCI stands for Peripheral Component Interconnect. And your Ethernet card actually goes on the same thing. So if you have an Ethernet port, it is connected to a PCI bus inside your computer. And it is designed by, not by IEEE, but it is designed by PCI Special Interest Group, which is called PCI SIG. And first there was a PCI, which actually I still have computers with PCI, but I can't find any cards for it because all the new cards are for PCIe, which is the latest version of PCI. PCI Express is serial point-to-point interconnect with multiple lanes, and you need 4 pins per lane. So you could, when you go and buy a PCIe card, which you can look up on Amazon, you will find 1 lane, 2 lane, 4 lanes, 16 lanes. The more lanes you have, the more speed you can get. You can get up to 2 gigabytes per lane, and you can get up to 32 lanes. So 64 gigabytes. It doesn't go very far. It's a very short bus. But, and that's how you can get all these big speeds for very cheap prices. I mean, like I just bought a PCIe card probably for $10. And I don't know how many lanes it has, but I mean, for $10, you know, what can you get, right? So that is PCI Express. Now in the PCI Express, the way it works is that there is a root complex. In the next picture I will show you. There is a root complex, and there are devices, which we call them functions. So basically, you put many devices. So you might have a video card, you might have a network card, you might have a disk on that same PCI bus. So the head of the bus is the root complex, which is generally near the CPU. The CPU is in charge. So that is the root complex, is the head of the function, head of the PCI, which is connected to the CPU. And then the physical function is their name for whatever is going on the PCI. So, for example, Ethernet is a physical function. Another physical function, it could be video. Alright? Now, they have extended it so that they can do virtual functions. So you could have one physical PCI, but it could do many different, maybe thousands of virtual functions. So now you could have just one NIC card, but this will provide, without depending upon the hypervisor, without depending upon the external switch, this NIC will provide 1000 NICs. So that is called single root IO virtualization, SRIOV. Basically, you might have, let's say in this example, I have shown 2 functions. There is a fiber channel card and there is an Ethernet card. These are physical functions of those cards. But both of these cards are SRIOV enabled, which means that they can provide you virtualization. So you can produce multiple virtual functions. These blue things are fiber channels and these yellow things are Ethernet. And there is single root hypervisor, which generally talks and keeps control of the physical resources, will keep track of the PF and tell them that, okay, I need 2 VFs and then connect the first one to this VM and connect the second one to this VM and so on and so forth, and then it gets out of the way. Once it creates those virtual functions, it gets out of the way, and then everything can go directly. So this VM thinks I have a fiber channel card, and this VM thinks I have a fiber channel card, and so on and so forth. I mean Ethernet card, and they basically use that. They just use those functions as if they were real functions. There is one single hub here, right? In the next slide, I'm going to talk about multi-root. So just hold on to that thought. So the single root is basically you divide a card into multiple pieces, virtual pieces. It's simple. Basically, your NIC cards can do all of this that we were expecting the hypervisors to do and things like that, right? Hypervisor is still involved, but they're not really doing any function. There is no code there to do any of this. They just create they just tell the PF that you have to do this, and then they get out. So now PCI didn't stop there. PCI guys, just like Ethernet, just like fiber channel, they said, why do we have to be in every computer? And they have their own fabric. Fabric means their own network. And they said the advantage of using this fabric is that your computer can be cool in temperature and in price. And you could have this thing externally, and many computers can use it. So here are your devices. You have one card, and I haven't put what kind of card it is. It could be fiber channel, it could be Ethernet, another fiber channel. This is all outside the box. So you have these blades, and on the blades you have these CPUs, physical CPUs, and now the cards are not going on the same place. They could be somewhere else, maybe in the next blade or in the next. Actually, don't go to the next rack, but maybe in the next level or something like that in the same rack. So these PCI devices are external and shared. So you save money. You don't have to buy that many cards. You could have 16 servers, but only 4 cards. And now, so you have these root complexes, which is in every machine. So there is 2 levels of virtualization here. These root complexes. And then these are called PCIe switch. These are not Ethernet switches. These are PCI. This is what is called PCI fabric, PCI network, right? So these devices are shared by these root complexes. And now you do the same game of I/O virtualization. So now each VM can get whatever they want out of this available thing, and this doesn't have to be physical. Up to this point it is physical, but when you come to here it is virtual. You could have 4 physical devices and share with 15 physical servers without going any virtualization, because only 4 need it, other 12 don't need it right now. They don't need fiber channel maybe, right? But with virtualization, every virtual machine can get a piece of whatever they need. This switch is a physical switch. Yeah, actually I have been clear about the dotted line here, correct. So the only thing dotted here is VM, and I haven't shown the BFs, but you understand those cards will have lots of little virtual functions. All right, the world is going crazy with virtualization. If you are going crazy with virtualization, that you can have a smaller number of devices. So this is actually for saving energy and saving cost. It is saving energy because you are not heating up all the cards when they are not being necessary at that time. And you are saving, of course, you are saving energy and saving cost because you are not needing that many cards. So this, I think we are done with the VNIC part. Okay, there are 3 ways to do VNICs. VEB, VEPA, and SRIOV. Actually, MRIOV is also there. Okay, so 4 ways if you want to count that before. One solution came from IEEE, one solution came from PCI SIG. 2 solutions came from PCI SIG and 2 from IEEE. Alright, so we are done with that. Now we go to totally different thing, is relocation, VM relocation. So remember we had talked about vMotion when we were talking about VMware products. And what does vMotion do? vMotion allows you to take a virtual machine and move it live when it is running to another computer. You don't have to stop the machine. You don't have to put it into hibernate mode. You just take it live and put it there. And so that means it has to have the same profile, same everything that it had on this machine, except the location has changed. So it has the same MAC address, same IP address, same VLAN, its new home. We need to extend the VLAN broadcast to this new home. So we need to make sure that the VLAN broadcast go to that position, that place. So after relocation, how does that happen? After relocation, VM sends a reverse ARP. I think we talked about this before. Did we talk about reverse ARP? No, maybe not. Okay. Reverse proxy was the thing that we had talked about. It sends a reverse ARP to all switches so that they learn its new location. So what is a reverse ARP? First of all, what is an ARP? Anybody knows what is an ARP? Yeah, and the reason is, if you don't know somebody's MAC address, but you know their IP address, you can ask the world. And this is a broadcast message. You send a broadcast message. Does anybody know the MAC address of this IP address? Alright? And anybody can respond. Whoever knows can respond. So that is ARP. ARP is address resolution, and we are resolving the MAC address. We know the IP, but we don't know the MAC, so we are resolving that. Reverse ARP is just the opposite. You didn't ask, but hello, please listen. My MAC address is so and so, or the MAC address of IP so and so is this. So you're just telling unsolicited everybody that this is the MAC address. Why you are telling? Everybody knows that already. You just had that MAC address a minute ago. But now the switches will learn that you are here. Right? Because that broadcast will go through all the switches, and the switches will know, oh, this MAC address was supposed to be on that port, now they are on this side. So that's the only way they learn is when you say something. If you don't say anything, they will think you are still there. So the first thing you do when you move is just say something. And it didn't have to do the reverse ARP, it could do any other broadcast. It will work equally well. Alright, reverse ARP. If a VM moves to a new data center to avoid tromboning. What is tromboning? So I skipped tromboning because it was in different part. I don't think I discussed it here, and I'm going to explain that in a minute. To avoid tromboning, a default gateway should be available at the new home. Tromboning. So let me see where I can explain you tromboning. Alright, I think this is a good picture to just explain tromboning. So let's say you have this one data center and you have this second data center. Right? Now you move from there to here. Your default gateway was here. Right? All the traffic that we are sending out of your network was going from here. Now you came here. So now what is happening is you are really very far from your default gateway. And so a lot of traffic is going to come to you, and then a lot of traffic is going to come to you from here for nothing, because you could have just gone out from here. If you had optimized this thing, there could be a gateway here that could help you. And in general, there are more than one gateway on the LAN, and you just select one because you don't want to confuse everybody. So you just use only one out of all the gateways that are there and use them as default gateway. Alright, so this is called tromboning. Tromboning is basically, flipping back and forth for nothing. Alright, and so these are the protocols which actually allow you to do that. First protocol is called HSRP, Hot Standby Router Protocol. So this is basically allows you to have multiple routers on the LAN, and one router is there and there is a standby router, hot standby. That is Cisco protocol, and VRRP is IETF version of the same thing. And VRRP is Virtual Router Redundancy Protocol. So basically it's same thing. You have two routers or multiple routers on the LAN, and one of them acts as the main and everybody else is sitting there standby. Yeah, you have to do all that calculation before whether you can move it. I mean, you have to have first of all a cool CPU, because you don't want to make something which is hot already to hotter. So you do everything, all kinds of
goes into a cool CPU.
Cool CPU means in the sense that which is not overloaded.
Not overloaded, but it's still a working CPU.
Yeah, they're not turned off. Yeah. I mean, first thing you will do is turn on the CPU, put the hypervisor in it, right, and see, if you have just turned off some VM, maybe you can give space for this. So all that is done in the background. I mean, this is a big business by the management of the cloud. Companies, they are making products and tools for this, and Cloudera is a good example. And it's a big business right now, managing, orchestration is a big word. Believe it or not, orchestration is a big word in the industry today, nowadays. The way these both of these protocols work is that you have 5 routers, and all of them have different IP addresses, just like they're supposed to have, but they also have a common VIP. Right? However, they never respond to it. If somebody says, what is the MAC address of this VIP, they will not respond. Otherwise, 5 answers come back and will be very crazy. Right? So only one who is master says, okay, here is my VIP address, this one, right? MAC address is this. So that VIP is basically the idea is that's how you get one router to all the traffic, is because that it has the MAC address. And then when that goes away, other routers come up. Then they will say, oh, VIP, the MAC address for router is this. This VIP address is this. Right? So now they become in charge. That's how it works. This is how those 2 protocols work. Remember we talked about this in ADC, that multiple servers can have the same VIP. They will have a real IP also, but they will have the same VIP. And only one will use it. Right, and based upon the MAC address, actually based upon the MAC address, the load balancer was sending it to the right place. Drum banning, yeah. So basically, those two protocols are simply how to have a standby default gateway. When we say standby or virtual, that's what we mean. So you have, okay, and you might have more than one. Okay, so what we are saying is that you will have one in this data center, one in that data center. And in this particular case where we are, if we move a VM from here to there is no reason for us to use this default gateway. Now we have to extend those protocols somehow so that we can use this data. When I'm here, I can use my nearest one.
So just a standby one.
Yeah, multiple standbys here. So let me say one more time. See, when the VRRP and HSRP were designed, the LANs were so small. Right? At that time, they didn't think that people would be far away. But now that the LANs are 100 miles long, if I have 5 routers on this LAN, they're not all equally good. Something which is 5 miles away is very different than something which is 100 miles away. Right? So now we really need more than one default gateway.